For this example in the series on how to evaluate limits at infinity of radical functions, the same set of steps will be applied. Given that the limit as x approaches infinity of root x squared plus 4x minus x all over 1 over x, how do you go about evaluating such? Remember, the next step is to rationalize, meaning we are going to multiply both sides by the conjugate. If you have, for example, root a minus b, its conjugate will give you root a plus b. Just by flipping the sign, we obtain the conjugate. Applying that here, we are going to have that the limit as x approaches infinity of root x squared plus 4x minus x multiply its conjugate, which is root x squared plus 4x. Instead of minus now, we are going to have plus x all over the conjugate multiply 1 over x will give us the conjugate over x, that is root x squared plus 4x plus x all over x. So for order, let's have it written like this: multiply 1 over x. The numerator can be written as difference of squares. For instance, if you have a minus b, multiply root a plus b, root a minus b, multiply this will give us root a minus b squared. So this can be written as difference of squares. Applying that here, we are going to have the limit as x approaches infinity of root x squared plus 4x minus x all squared all over root x squared plus 4x plus x all divided by x, which is multiply 1 over x. Now for the numerator, we can expand this just as we have here. This can be expanded to have the square of root a. So we have root a squared minus b squared. Applying this to this expression, we will have the limit as x approaches infinity of root x squared plus 4x squared minus x squared all over root x squared plus 4x plus x all over x. From here, this can cancel out the root so that we have the limit as x approaches infinity of x squared plus 4x minus x squared all over root x squared plus 4x plus x all over x. from here we can see that x squared cancels out x. X squared here cancels out minus x squared, so we are left with only 4x. So this will imply that the limit as x approaches infinity of 4x all over root x squared plus 4x plus x all divided by x. The next step here is to factor out the highest root, but before we do that, let's simplify the denominator that looks complex even though it is not. Now if we rewrite that expression, what we are actually having there is the limit as x approaches infinity of 4x. Okay, let's have it here. Let's just rewrite this here. We have 4x divide root x squared plus 4x plus x all over x. Mathematically, we can cross multiply, right? So that we have x multiply 4x all over root x squared plus 4x plus x. So, and 4x multiply x will give us x squared. So let's have that here. So we have 4x squared all over root x squared plus 4x plus x. Now we can factor out the highest power in the root. So we have the limit as x approaches infinity of 4x squared all over root x squared in 1. So x squared multiply 1 will give us x squared plus 4 multiply x squared will give us 4x squared. But what we have is 4x, so we divide by x, so that balances up all the elements in the root. So plus x. And we know that the root x squared can be written as x squared to the power of 1 over 2. So that 2 cancels 2, we have x left. If we apply the same here, we are going to have therefore that the limit as x approaches infinity of 4x squared all over x multiply root 1 plus 4x plus x is common here, so we have 1, so that x multiply 1 will give us x, so that balances up, and from here we see that these can cancel out x. Here we have 4x left. We can now substitute the value of x as x approaches infinity. What is the value? Let's solve that here. So this will imply as x approaches infinity, we are going to have 4 infinity, so we'll do direct substitution all over root 1 plus 4 over infinity plus 1. And 4 multiply infinity will give us infinity all over 4 divide infinity is 0. 0 plus 1 is 1. Root 1 is 1 plus 1 is 2. And the 2 Infinity divide 2 will give us infinity. Any large, very large value divide by 2 will only give you very large value. So infinity is the final answer. If you find our video helpful, please like, subscribe to our channel and share. Thank you for watching.